Okay, and we will go on with the agenda, and our next speaker is Mr. Carsten Strampe, CEO of Imago Technologies. And Mr. Strampe will speak about what's behind latest technologies, and he will speak about and explain AI, deep learning, and the event-based vision. So, Mr. Strampe, the stage is yours.
Thank you, Mr. Dietrich. Okay, so what's behind new technologies, AI, deep learning, and event-based vision? My name is Carsten Strampe. I'm the General Manager of Imago Technologies, and in the upcoming minutes, I will explain how machine vision becomes more intelligent, some words about deep learning, and quite interesting is also to learn something about event-based vision. And I'm available for question and answers. Just a quick overview of Imago Technologies, what is our portfolio. What you see here is on the left-hand side a number of vision computers. We serve here many different machine vision interfaces, different CPU architectures, so from Intel x86 to multi-core ARM, up to NVIDIA's CPU, GPU. And if it looks like a camera on the middle and on the right-hand side, it's still a vision computer. So we do not invent and produce cameras. We invent smart cameras and vision sensors, always with a multi-core CPU inside, always with a Linux operating system. Now, machine vision becomes more intelligent. Probably you heard about it. And if we take a look at Wikipedia and we read about artificial intelligence, so we collect data from machines and we put them into some learning models and we create new information. And with a deep learning, it's a new method for machine vision, because instead of specific algorithms, we start to give images into the system, do a learning process, and then compute on these images. So what happens here? We take a look into the way our brain is working. And in that context is the same on the side of the sensor. We take a look how our eyes and the connection to the brain works. And this kind of neuromorphic principle is implemented in the technology called event-based vision. So first step, here's something about deep learning. First of all, how does it works? Very easy explanation. First of all, you have to define image classes. So singular images, you put them together in an image class, and you have to annotate these images. And for example, you define 5 different classes with, for example, 50 images per class. The second step is the learning process. So a specific deep learning model is used, and this model takes the images and creates a so-called inference program. And this is the execution for the vision system. The inference program is the decision maker after the learning process. And these are the main steps to create a deep learning-based vision system. At Imago, we invented a new product. It's called VisionCam AI Go. What's behind? On the image, you see, let's say, a housing of a camera. But inside of that camera, we have implemented all the processing power to run a complete deep learning system. Very special is the concept that we already are able to do the learning process inside of the camera. Of course, not in real time, but we don't need any cloud access or any external GPU-based computer. You put the image classes into the camera, push a button, do the learning, and after a time, the camera is ready for the inference. We as Imago offer that, let's say, product to start with deep learning, and we have also an infrastructure behind us. Together with our partner company, Aerobics, we are able to modify the deep learning model. We can do a kind of optimization, and of course, we can adapt all the parameters to your specific application. So that is our approach with deep learning. First of all, to provide an easy-to-use solution to enter into that sector of deep learning application, and then hopefully it already works for your specific idea. The next topic is event-based vision. So event-based vision, I start with probably you have at home a hedge trimmer. It's a nice example. Because the hedge trimmer provides us a very fast-moving mechanical unit. I hope it works, yes. So what we see is really nothing. If you want to analyze that movement, you need a high-speed camera. You need the right illumination, 500 frames per second, for example. You need a big computer to analyze the data, so not easy. These kind of high-speed applications are very expensive. And if we switch that scene into event-based, it looks like this. So we already see some data. So it seems to be interesting to analyze these fast-moving objects. The next scene shows a typical complex background. Often in machine vision, we have very complex backgrounds. It's not so easy to compute on them. And the following example shows a motorbike. A motorbike moving into the image. The motorbike stops for a few seconds, then it disappears. And the task is to say, did the motorbike stop for 3 seconds or not? Or was it just moving? So here we have the motorbike, it stops, and with a classical machine vision approach, it is not easy. We need the frame grabber, we need the cameras, we need the data transfer into the computer. We need a background calculation. We need to extract the object motorbike, we need to follow the motorbike, and then we have to decide, okay, did the motorbike stop, yes or not? This was the former classical approach. And if we look at the data from event-based technology, first of all, we just see events coming from the motorbike. No background, no extraction. And these are data coming directly from an event-based sensor, camera sensor. So there is no pre-processing necessary, there is no FPGA behind. These data are the output of an event-based sensor. So the advantage of the event-based approach is that, first of all, we do not have any more images. We have just event data. It's very easy regarding very complex background, not moving backgrounds. And as you can imagine with that scene before, you can summarize and cluster events, follow the cluster, and discover if the motorbike stops, yes or not. So the data processing can become more easier than in the past. How does it works in more detail? Here we have a classical scene and typically many redundant data. Yes, and for example, we want only to discover that moving car. And with the event-based approach, we receive here data with some, let's say, darker and brighter pixel, and these are rising and falling edges in the practical approach. And if we look on the sensor itself, how are the events generated? So in the first scenario with the T0, nothing happens. And then the third pixel itself discovers an event. And just that pixel sends the message with the location of the event, with a timestamp, to the vision computer. And in the third row, the second pixel creates an event, and maybe the third pixel, the event disappears. Also, the pixel itself sends the coordinates, the timestamp, and if it was a rising or a falling edge. The sensor itself creates these type of events, is connected to a vision computer, and we are Imago, so we already integrate the vision computer into our event-based camera. And as you see on the left side, the pixel location, the type, and the timestamp itself moves into the memory with a resolution of VGA, a high dynamic range regarding the sensor. And these data are computed inside of the VisionCam EB. Inside of the VisionCam EB, we use a dual-core ARM CPU together with a Linux operating system, and then you are free to compute on the data. As the data are, let's say the data is just a XY matrix changing over the time. To have a better understanding, we provide the so-called XYT viewer. And here you see the events over the time, and also with a 3-dimension. And this tool helps a lot to understand the data and to have an idea what is needed to create the result and what is needed regarding algorithms. As said before, we created a complete embedded vision system with the event-based sensor from Prophecy, VGA resolution, and we are using that architecture, and that is used to implement the complete application into a smart camera. With a gigabit Ethernet and I/Os, etc., that device is ready for many industrial applications. A next topic from Imago is that we are open for specific OEM developments. So we have already created a new device, a very small camera. It acts more like a sensor with the event-based sensor inside, optimized for a device of our customer, together with additional software. So in the meantime, we have 2 years of experience regarding event-based ideas, approaches in machine vision. We are very familiar with that technology. That's from my side. I thank you. I'm in time for minutes. Mr. Dietrich, maybe you have a first question.
Okay. Thank you very much for the nice presentation, first of all. And also, thank you for staying perfectly in time. That's not the usual case. So, first question. Were you the guy on the motorrad?
Sorry?
Were you the guy on the motorbike?
No. It was really incredible, the story behind the motorbike. We asked 3 students from our university in Friedberg, and we gave them a camera and an event-based camera and said, please play with it. Understand how event-based works, and create some nice examples. And one of them is the scene with the motorbike. So it was a student from Friedberg.
Okay, pretty good. And yeah, you showed some major application. One was the cutting edge example, and of course the motorbike. What are other possible applications? Event-based vision
yes.
Can outperform existing systems.
In the meantime, we have spoken with a number of industrial customers, or probably customers. And one topic is fast counting of objects. Then we tested vibration control in every scene. So these are very fast, small movements which you can discover with event-based. Another application is, we call it kinematic control. You have a mechanical unit moving very fast, moving all 24/7, moving very fast. And sometimes there is a deviation, which you can discover by the speed or acceleration, whatever. And you want to discover the deviation of that movement to set an alarm, to stop the machine, to prevent an accident. I think that's quite interesting because machines, they are running faster. And finally, let's say some products, you have a folding machine, a fast folding machine, and sometimes there is also an accident. With event-based, you are able to discover that accident before it happens.
Okay, thank you. Last question. When we speak about the AI approach you've showed, and you do this in collaboration with a partner company, how can the customer handle possible big amount of training data, positive examples, negative examples, and so on? Can you say something about the workflow to get in touch with it?
Let's say we have two solutions. One of them is our so-called Vision AI camera. It's like a Linux computer with an accelerator. That is foreseen for AI experts. They are free to put their own application into that camera, complete open platform. And our Vision Cam AI Go is a more, today, first closed product for, let's say, a limited functionality. Okay, and between there are many different ideas. It depends on the customer application.
Okay, okay. Thank you for answering the questions.
You're welcome.
Thanks again.
Thank you.